Hello and welcome everyone to today's episode. Today we are going to be covering the following topics. All the timestamps are in the description below. And I hope you enjoy today's episode. So let's get started on these topics. So previously we looked at running a simple SQL row query in Entity Framework, and we saw how Entity Framework still maps a simple query because we're pulling from the students table and we already have a model in our C# application for student. It's able to match the object that we get back from the SQL query to the C# code. Because the student class over here, you can see student class over here maps correctly, and we are able to do things such as loop through the student object that we get from the list of students over here, and this works as expected. But did you also know you can do complex things, such as you can actually write a complex raw SQL query? So here we're doing the select star from S, so this is the student, and you can see here that I'm doing an inner join against the students and subjects, and I'm checking which of the student doesn't have an active subject at all. So we're looking at where one of these students will not have an active subject, and then we're just going to loop through them and print the student's name. So what happens is, because we're only selecting the data from this table over here, notice it's select S star from this table. Entity Framework is able to map all the relevant fields from this table over to the student class that we have declared in our C# code, so it doesn't have any problems in mapping the fields. So if I run this here, and we should get an output of one student here, John, because John doesn't have any subjects in the data. If we look at the database, you can see this is the query that we run, and if you execute this, John doesn't have any active subjects. So if we look at the student subjects table, so you can see student ID 1, 2, 3. 3 is John's ID, and you can see although this student he is active, but in terms of subjects he's doing, he doesn't have an active subject, while the other two students do have an active subject that they have enrolled onto. So this query here is what we expect. We want just basically this row of data, and you can see here we have replicated that within Entity Framework row SQL query by using the from SQL interpolated method, which also prevents SQL injection attacks, as we saw in my previous explanation. So you don't have to do simple queries like this. So previously we said you can do complex queries like this, and Entity Framework is able to map these complex queries here, where we are using, for example, an inner join against another table. And this table over here is actually not a model in our Entity Framework application. So you can see we only have a student and a teacher model over here, but we don't have any other DB set other than these two. So by using the row SQL and by us pulling the data just from the students table over here, is able to match every single value from that table over to our class object. But if we now start to use this table over here, SS, which is student subject. So if I just add SS over here, and now we're pulling the item from this table rather than the student table for which there is a C# object. If we run this, you'll see that we'll get an error message. And if we have a look at the error message, the required column ID was not present in the from SQL operation. This happens is because, as you can see here, we are using the context of students. So what it's trying to do is trying to map the values to the students DB set, which is based on a student class, and the student class has the following fields that it expects: ID, name, age, city, and is active. And notice that these fields are mandatory because they do not have the question mark to enable null values. So when we got this error, it's basically telling you that ID was not present. The reason the ID was not present is because this table over here, SS, which is student subject, and if we have a look at the student subject table in the database over here, you can see it doesn't have an ID column, but the ID column is a required field in our student class over here, because again, it doesn't allow for null. But one interesting thing that you will find is if you now do select star over here rather than from S star, so it's not putting the field only from this table, but it's pulling fields from this table too, what you should find is that our code works. So if we run this again, So if we select all the columns from both tables, you will see that our code does work. So you can see we got an output of John over here. And the reason this works is because in this table, we have the additional column student ID, subject ID, active, which do not have the same names as the columns within this students table over here. So the column names are different. So when Entity Framework tries to map against the student's DB set or the student class, what it finds is it finds all the relevant fields are available because we have done a select star. So it finds the ID, the name, the age, and city, and is active and is able to map them. So this is important to understand that although select star works, but you may get naming conflicts, but you cannot get the fields from another table over here because those are required fields over here by the students class. And we'll continue discussion on this and continue to expand our knowledge around why and how can we get around getting a custom object from row SQL and still use Entity Framework. We map it. In Entity Framework, you can use row SQL. As you can see here, we have some row SQL over here, but notice that we are using students DB set, so essentially student table, but notice our query does a select star. What this means is it's going to pull the fields from this table called students and this table called students subjects. Now, if we go over to SQL Server and if we have a look at the students table, you can see that it contains the following columns: ID, name, age, city is active. Now, if we have a look at the student subject, you can see it has student ID, subject ID active, but then we've got the ID column over here. The ID column over here and the ID column over here have both got the same name. So if they have the same name, you can see the problem will be with this select star, because what it will do is it will get the students from here, which will have an ID column, and it will get a student subject, which will also have the ID column. So when it does the mapping against the student DB set or class, so here that's our student class, for the ID field, it's going to get confused and it won't know which one to use. So in this instance and in this version of Entity Framework, if I run this, you can see that we will get a runtime error. So here you can see we have a runtime error and it says unhandled exception. An item with the same key had already been added. So here key ID. So this error occurs because both of these tables contain the same field name. In this instance is you need to do select from the S alias over here, which is the students table, and then you won't get any field from this table student subject. So if we do that and run our code again, you will find that we do not get any errors and our code works. So here you can see our code does work and we do not get any errors. This is because the mapping had been done correctly. So it's important to watch out to not use select star if you have columns or fields in your database that have the same name across the tables. So don't do select star, instead select specific columns from a specific table that map to your class. So in this instance, you can see this is the student class and we were able to do a select star from the student because all the fields that are over here actually do exist within the backend table. And that's not an issue. One of the great things about Entity Framework is that it automatically maps the fields from your row SQL into classes that you have. So here I've got a class called student. This, as you expect, is what we are saying is a DB set as well. So by DB set, what we mean here is we are saying that this student class over here is actually one of our tables that exists within the database. So we are saying we will have a table in the language of Entity Framework known as DB set, and that table will have the following properties. So in this instance, you can see it will have an ID, name, age, city, and is active. So the great thing is when you issue row SQL like this using Entity Framework's method over here. So we're accessing the method using the connection. So that's the context that we created. And then we are accessing the students DB set, students table. And then we are accessing a method called from SQL interpolated. And this takes in row SQL that you can write. But notice here, we're doing select star. So it will automatically map all the fields from this table in the database over to the properties we have in this class. So you can see the ID, the name, the age, the city, and is active. The way it's able to do this is if we have a look at our database here, we have a students table here. It's got ID, name, age, city is active. But you will notice that there's an additional field here called country code, which doesn't exist within our C# code. So if we go back here, we've got is active, but country code is missing. So when it does execute this SQL statement, what will happen is it will map all the fields that exist and match the names in the backend database versus what's over here. When it finds the field in the backend database that doesn't actually exist within the student class, it will simply ignore it. So it will not map it across. But the other way around is not true. For example, if you have a field that is a required field here, so that, for example, doesn't take in nulls, then you will have a problem, which is it won't be able to map that field. So let's demonstrate this. So at the minute where we'll just do a select S star, and we know there's an additional field in our backend database over here. So if we run this over here, and you can see that our code works and there are no issues. So the additional field here, country code, is simply ignored by the entity framework because it does not exist within the class. Within entity framework, if you have a table called student, for example, so here I've got a table called student, and then you have a field called city. For this city field, you can see we've added a question mark next to the data type. This question mark basically says that this field can have null values, so it's optional rather than mandatory. So you get into this situation and you think, well, that might mean that entity framework won't look for that field in your database. That's not true, because this field is part of your class over here, student. And when we have a DB set here, which essentially tells the entity framework that we actually have a students table in the backend with the fields or the properties that we have defined here. So these properties must exist. So what I have done here is the city column I have renamed to city to make entity framework think that this column doesn't exist. So you can see that we have all the other columns, but city column won't exist because it's called city 2 here. So when entity framework tries to do its mapping, so if we go over here to our query that will be run, so you can see we're doing the select star from students table, what it will find is it'll find a city 2 column, but it won't find a city column. So we should get an error. So if we run this, you can see that we get this long error. And if we scroll to the top of this, then you can see the error is over here that basically reads invalid column name city. So here we are getting invalid column name city error, invalid column name city error, because they cannot find that column. However, what we can do is we can actually specify the columns in our select statement over here. So you can see we've specified the ID column, the name column, the age. But when it comes to city, you can see city 2, we are aliasing as city. So what happens is this code will now work because city column here has been aliased, and this will map against the city property within our student class. So the mapping within entity framework works as expected. So if a column has been renamed, you can use this technique for your rule SQL. So if I run this code over here, you can see that we got no errors here and our output is printed. But by simply, if we just didn't do the aliasing part, so we just left it as original name and ran our code, you can see that we've got this long error. And if we scroll up over here, it says the required column city was not present in the result from SQL operation. So that means that it was unable to find the city column because we did not alias it. To fix this, what we have to do is just alias it as city and run our code again, and you can see the code works. So just remember this technique, that you can use the aliasing technique over here if the columns have been renamed and you are using row from SQL method over here, and then there should be no problems with your entity framework mapping versus what's in the database. In entity framework, you may have a class called student, which maps to a student table. But what if you wanted to create an object in C# that doesn't actually contain all the properties of a student class or a student table? What you need to create in that instance is called a student DTO. DTO stands for data transfer object. This is the C# vanilla flavor class or plain old C# object POCO that has the fields that you want. And then what you can do is, using entity framework, you need to register that with entity framework within the on model creating, which is within your DB context class. So here we inherit from DB context, and we created a class called school context. And within here, we have the one model creating, and we are going to override that. And when we override it, we are going to add in model builder entity, and we're going to add in our student class name for student DTO, data transfer object. And we're just going to say it has no key, because if you look at our class, it has no key, whereas the original class does have a key. This may be used in a situation, for example, for your front-end application, or for example, an API call where you're only interested in name and age and nothing else. So in order to use this, what you need to do is when you query your data, for example, in this instance, we are going to use this from SQL method, and you can see we are only putting in the name and the age from the student's table here. Notice here we are using context.set, and in the angled brackets, we are putting in our student DTO, and then the rest of it is same as any old entity framework code. So the only difference here is these two commands, which is set, and we're just applying it with our student DTO. And what entity framework will do is it will look at student DTO and map the fields coming from your query here, name and age, to the student DTO class. So this class basically will let you transfer from complex objects into simple objects that may be needed somewhere in your program. So here you don't need everything, for example, so you wouldn't reuse this class. So instead you have created a smaller class that only has the relevant properties that you need. So if I run this code, you can see here we are then just looping through and printing out the name and the age of the student, which are the two properties that are available. So this object here, student DTO, could be passed to other places within your program, or if you have a web API, then it could be passed there as well. So if I run there, and here you can see we've got the output, which is John and 21. So this is a simple output just to demonstrate the DTO options within Entity Framework. Remember, DTO stands for Data Transfer Object. So previously we looked at creating the student DTO. There are some caveats that you need to understand are important. When you use the student DTO, you need to make sure within your DB context here, so DB context class. So in this instance, we created our school context class that is derived from DB context. It will have an on model creating method. You need to override that method over here, and then using the model builder entity and the name of the DTO, you need to add has no key. If you don't do this, your code will not work and crash. So another thing to recognize with DTO is because it has no key, it is not tracked by Entity Framework. So you cannot go and make changes to the data within your DTO, such as the student name or age. You cannot change it. If you change it, then those changes will not be saved, because this is not full Entity Framework class. It is not a DB set as such, so you cannot use it to update anything. In order for it to be DB set, you need to make sure that it's actually declared as a DB set over here. For example, we got DB set for student here and teacher here. Now we could convert this to a DB set, so that would be simply by changing it to students, and then this is what it would be. So if you have this over here, then you know this is a DB set. So with the DB set, if you do a save changes method here, then this would save the changes. But when you do a set over here, so here with the student DTO, what would happen is when you do save changes, it will not actually make any relevant changes to the name of the student, because this is not a DB set. This isn't a full Entity Framework object, so it doesn't track changes back to the database. So this save changes here has no effect, because essentially you are just chaining the plain old C# object, and you are not chaining an Entity Framework tracked object. So I hope this makes sense in terms of limitations of a data transfer object with the Entity Framework. So we created student DTO here, and as you know, DTO stands for Data Transfer Object. So why would we want to separate from the Entity Framework class here, student, which is used by Entity Framework to update the database? So why would we create a data transfer object? This could be used by an API, for example, or a front-end user interface that only needs the name and the age properties rather than the whole object that we have here containing ID, name, age, city is active. So these fields fields may be unnecessary. So your program doesn't really need to know the entire entity for a certain specific task, whether be it displaying it on UI or responding to a web API request. So you do want to separate the concern between database and the actual layers that exist on top of the applications, such as the UI and API. So here you can see that you can actually populate the data transfer object using entity framework. So you can use the context and then the set, and then you can issue any SQL statement basically that is able to be run on your database. So in this instance, you can use joins, you can use any where clauses, pretty much anything that you want. You can select the columns that you need, and that would populate your DTO. But remember, the column names need to match your DTO class. So in this instance, student DTO has the following two properties, name and age, so they must match. So if we have a look at the benefits, so you've got security, you can hide sensitive fields using a DTO, such as password, internal IDs. For performance, you only need to transfer smaller payloads of data. So that's another reason to use a data transfer object. And another reason is separation of concern, because the UI or the API doesn't need to know the full entity structure. And of course, you can use it for data shaping, which means customized output. You can actually have additional computed fields if you want. So yeah, just remember some of these benefits: security, performance, separation of concern, and data shaping. So DTOs are very easy to use in Entity Framework. Just make sure within your context class, so that's the one that inherits from DB context, you add on model creating, you add a DTO, student DTO entity, but make sure it has no key, because in our instance, we do not actually have a key within here. So the key is normally a field that is an ID field, and then this will work flawlessly with Entity Framework. So here is a practical use of DTO, data transfer object. So here, as you can see, we have some complex SQL over here, and what we want to do is we want to just actually see the result of the SQL as summarized data. So we just want the name of the student and the number of subjects that the student is enrolled in. So we're just doing a count of that. So here you can see student table here and student subject. Now, if you look at our Entity Framework application, we do have the student class, but we do not have a class for the student subjects at the minute within our data over here. So what we want to do is we want to create a DTO called student summary DTO, and all its job is basically to store the student's name and the number of subject that the student is enrolled into. So that's the number of enrollments. So this is a very simple data transfer object that does not represent the original class of student. It's just completely different shape of the data, big summary level information. So what we want to do is we want to use this SQL. We want to use the Entity Framework. So again, you can see here context is over here. We want student summary DTO, which is not DB set. So notice it is just a set. So you cannot use it to update the database. So if we go down here, you can see that we have added it to our on model creating, and we've set it as a valid entity, but an entity that has no key. So that means that it's unable to relate back to the database with any primary key and so on. So when we get this, the advantage over here is our data output is completely different, because the number of enrollments is not in the original backend table. This is a calculated piece of information that we can use using SQL count function. So when we run this, we want to print out the name of the students and number of subjects the student is enrolled into. So if I run this code, and here we get the output that we were looking for. So here you can see we've got student Ali with 1 enrollment. John has not been enrolled into any subject, but Sarah has been enrolled into 1 subject. So this shape of data, which would have been quite cumbersome to work with otherwise, by simply using a student summary DTO, which we created. So we created the student summary DTO. We were just able to get the name and the number of enrollments very quickly. So this is a practical use case of using a data transfer object, also known as a DTO. And I hope you found this useful.